So this is a screencast offering a solution to the IB Maths Studies past paper exam style question on the volume and surface area of cones. So here's the question with a little diagram. A cone has a base radius of 10 centimeters and a perpendicular height of 15 centimeters. Part A, work out the slant height. Just get a feel for the rest of the question. Part B, the volume of the cone, and then the total surface area of the cone. Well, important to have a little diagram to help you there. There's the base radius, and that's going to be 10 centimeters. Here is the perpendicular height, and that's going to be 15 centimeters. And this side here on the curved surface area is the slant height, which shall be called L. So to start this question, I need to extract that triangle there by looking at the sides. So that's 10, here's my right angle, that's 15 and that's L. So I know I can use Pythagoras' theorem to say that L squared will be equal to 10 squared plus 15 squared. Okay, and I'll do some quick maths on there. I'm going to have 100 plus 225, and then that's a total of 325. So the slant height L is going to be the square root of 325. Okay, so I'll grab my calculator and I'll go for square root of 325. Now, depending on your calculator, you can find these terms in different places. Some of you need the math menu. I find for square roots, one of the easiest ways to do it is just to go for to the power of 0.5. So I'm going to do 325 to the power of 0.5, because that's the same as square rooting. Okay, so I've got my answer there. I got 18.02775638, and as we've done in previous examples, I'm going to suggest that you write the whole answer down, the whole calculator display. So I've got 18.02775638, and then I'll round it to three significant figures before I move on. So that's going to be 18.0 to three significant figures, and not forgetting the units, centimeters. Okay, so for the next part of the question, we need to know the volume of the cone. Well, just to remember that in our formula booklets, we have the formula for the volume of a cone. It's 1/3 of pi r squared times the height of the cone. Okay, so in this case it's going to be 1/3 multiplied by pi multiplied by 10 squared, because the base radius is 10, multiplied by 15, which is the height. So again, back to my calculator, I can put all of that in one go. 1 divided by 3 times pi times 10 to the power of 2, or I can use my squared button there, times 15, and all of that in one go, and I've got this answer there, 1570.796327. And again, I'm going to suggest that you write down the whole answer on the calculator display, 1570.796327, which then rounds to three significant figures as 1570. And again, to be consistent with the units, make sure I include centimeters cubed. So for the next part of the question, we need to work out the surface area of the cone. Well, to be sure we know what we're doing, we've got in our formula booklets the formula for the curved surface area of the cone. So the total surface area is equal to that bit, which is pi r L, plus of course the base, which is a circle, which is pi r squared. So if we look at pi rl, at this point we have a little bit of an issue because it's good to avoid using rounded numbers as much as possible. So what I've got is I've got pi times our value for L, which is 300, the square root of 325, times by the radius, which is 10, plus pi times the radius squared, which is the circle. Because that was, fairly easy to include, I felt it was probably safer to do so. And again, this can be done all in one go on your calculator. I'm going to clear my calculator screen here for the benefit of clarity. So I'll just clear the screen there, that makes life a little easier. And I'm going to start with the first bit. So I'm going to put that in brackets because I want to add these two things together. So that's second function pi times by 325 to the power of 0.5 times by, just need to make sure I've moved on a step to bring the cursor back down onto the main line, times by 10, and then that's the first bit, so I'll close brackets. Then I want to add the next bit, so I've got open bracket pi times 10 squared, close bracket. Now I've got that all going on in one go, and my answer there, 880.5179353. So I'm going to put it all down in one go, equals 880.5179353, and at that point I will round it to three significant figures. It's 881 centimeters squared. Remember that we're talking about an area there. And there we have the answers to all three parts of the question.